Hi, welcome to Chapter 14, Evaluate Finite Differences. Finite differences is a way of using tables to find equations of certain problems. And then once we find the equation of a problem, then we're able to answer the question. So we're going to be using a table to find the pattern, and from that we're going to find the equation. Alright, so let's just go through an example. So Joe was creating an input-output chart. He created two functions and he wanted to know the missing values. The first table is given. Can you figure out the function used? Okay, so he just wrote down some numbers, and the x is my input, the y is my output, or in other words, the answer. So what we're going to first do is we're going to first find the pattern. So I'm going to write down my steps down here. So find the pattern. Alright, so let's do that. If I go in between the 3 and the 7, I can see that that's a difference of 4. Between 7 and 11 is also a difference of 4. 11 and 15 is also a difference of 4. So I think I found my pattern. Okay, so what we're looking for is, we're looking for the next one. Well, that's pretty easy. If I add 4, my next number would be 23. But now, we skipped all the way to 137. I don't want to do that 137 times. So what I want to do is I want to find my equation. So what I want you to know something first. If the pattern is found on the first step, like we did here, it's going to end up being a linear function. So if pattern is found on the first try, it is a linear function. Okay, and we need to remember, what is a linear function? A linear function is written in the form of y equals fx plus e. Some of you might know it as mx plus b. I just use different letters. Okay, once we find that pattern, what we're going to do is we're going to write down the finite difference table. Okay, so let's do that right here. Finite difference table. Okay, so we're going to have x and y. And basically, we're going to make a table of values. And we're just going to plug in 0, 1, 2, 3, and 4. What are we going to plug them into? We're going to plug them into our linear equation. Okay, so let's do that, and we'll do it underneath the table. So if I plug in 0 for x, I get y is equal to f times 0 plus e. Well, 0 is 0, so 0 plus e is just e, so y equals e. So that's going to be my answer here. Okay, so let's plug in the 1. Y equals f times 1 plus e. Well, f times 1 is just f, so y equals f plus e. So the answer is f plus e. Let's do one more and then you'll see the pattern. Y equals f times 2 plus e. Well, y equals 2f plus e. So this is 2f plus e. This is 3f plus e. And this is 4f plus e. Okay? So then what we're going to do, once we write the finite difference table, we're going to find the pattern in that table. Okay? So from there to there, we added f. From that step to that step, we added another f. So if you can see, we found that pattern. Okay. Once we find the pattern, then the next step is to line up corresponding parts. Okay, so let's do that. I'm going to use purple. Actually, I'm going to use a highlighter. I'm going to look at my first answer, which was a 3. Where is that same spot on the other table? It's right here. So that's telling me that E is equal to 3. Let's highlight another corresponding part. Let's use blue. So another corresponding, so my next spot is 4, and that corresponds with F. So now that's telling me that F is equal to 4. Okay? Once we do that, we want to fill in the linear equation. Okay? So if you remember, the linear equation is y equals fx plus e. So what that means is the 4 will go here and the 3 will go here. So my equation is y equals 4x plus 3. There's my equation. Now that I found my equation, I can, I'll put that step right here, solve. Okay, so we want to solve when x equals 137. So y equals 4 times 137 plus 3. So y is equal to 548 plus 3 is equal to 551. And that's my answer. Okay, so that's a linear equation. Let's try, well, here's another linear equation. Let's try another one. Okay, so if you notice here, in this one, we didn't start with 2, we didn't start with 0, we started with 2. So let's do the same process. Let's find out our pattern. So we subtract 3, we subtract 3, we subtract 3, and we subtract 3, and so on and so forth. Okay, so here all we want to do is let's write the linear function. Okay, so we have, remember, y is equal to fx plus e. So let's write my finite table. Here's my y. 0, 1, 2, 3, and 4. Okay, if I plug 0 in, I get e. If I plug 1 in, I get f plus e. If I plug 2 in, I get 2f plus e, 3f plus e, and 4f plus e. This is a difference of f Okay, and the reason I give you this table is because I want you to line up your corresponding parts. So the 14 is actually, careful, it's going to line up with the 2. So we're going to have to start here, not at the 0. So let's line that up. So what we're saying is that 14 is equal to 2f plus e. Okay, so let's line up the next one down. So if I go down, we got f is equal to negative 3. Okay, so now I'm going to plug it in. So 14 is equal to 2 times negative 3 plus e. So 14 is equal to negative 6 plus e. Add 6. 20 is equal to e. So we have f is equal to negative 3. 20 is equal to e. So now I can write my equation. So y equals fx plus e. Let's plug our stuff in. Y equals negative 3x plus 20. And that's my equation. Okay.